Meet what was to be the Russian answer to the F-22 Raptor. Being able to carry more missiles and even shoot backwards, this jet was to be the pride of the new Russian Air Force. But instead, it turned out to be the downfall of the famous MiG Bureau. Today, we'll be exploring the last big project of the Soviet aviation industry, the curse of 90s Russia, and how Sukhoi ended up taking over the Russian 5th jet program. This is the MiG MFI. Our story actually begins in the early 80s. Russia was becoming aware that the capitalist Americans were building a successor to the F-15. To not be caught with their pants down, they commissioned their own equal project to replace the Sukhoi Su-75 and was looking to recreate the success of the famous MiG-25 Foxbat and its successor, the MiG-31. The main requirements tasked to the various aerospace bureaus all over the USSR were as follows: super maneuverability, multi-role ability, supersonic cruise speed without the use of afterburners, and a low radar cross-section. The development of the new fighters started slowly and two main competitors came out of the pack, MiG and its forever rival, Sukhoi. When the Soviets found out that the ATF program had selected the Lockheed's YF-22 as the next US air dominance fighter, the government set the highest priority for the MFI and LFI programs to counter this new threat. And the MFI was to be the new heavy multi-role fighter, and the LFI stood for light one. MiG had the big brain move to design both aircraft to utilize as many components as possible and keep costs down, winning the contract. But this win would also seal its tragic fate. The new aircraft series MFI got the designation I-90, meaning Fighter 90 or Fighter for the 90s. Requirements stayed pretty much the same, and after testing various models in the wind tunnels of TSAGI, the final design was chosen. The MFI had a pretty standard delta wing configuration, but with some interesting details that make it a pretty unique plane. Just like the Rafale or the Eurofighter, the front of the aircraft had canards, because delta wing designs are known to be less stable without them due to the lack of horizontal stabilizers. Large variable intake ramps similar to the Eurofighter would allow a steady flow of air during even the high angle maneuvers, and S-shaped ducts would hide the compressor blades, ticking both of the first two requirements. Engines powering the aircraft were Saturn AL-41Fs, and they should not be confused with the AL-41s used on the Su-35 and Su-57, because these engines were completely different. The only reason that they weren't used on the Su-57 is that they were simply too large. MFI's engines also had thrust vectoring nozzles along with ceramic plates on the inside of the nozzles to lower the IR signature. Even though the flying prototype didn't have a weapons bay, the 1.42 prototype, one made for static and ground testing, had it and could fit an impressive 12 missiles. This would allow for a large amount of weaponry in a full stealth configuration if they only used the internal bay. But when they decided to use the external hardpoints as well, they would be able to sport large air-to-ground missiles like the HAR-29, 31 and 55, and others, making it a truly multi-role fighter, ticking the last requirement. Another novelty with this aircraft was the ability to launch missiles towards the back, shooting down any enemy planes during a dogfight if the situation was dire for the pilot. This ability was being developed namely for the R-60 and R-73 missiles. Large canards in the front had also a dog tooth, or a small extension which would help in stall resistance and with maneuverability. In conclusion, all of the design choices were made in compliance with the requirements set and promised a very serious competitor to the Raptor in the future. But alas, in our story, very soon, everything went wrong. To say that the 90s changed everything would be an understatement. With the dissolution of the USSR, many projects came to a full or a partial stop due to lack of funding. But with this program, it was a different story entirely. The MFI and LFI programs, along with the T-10V, which would end up as the Su-34, were top priority programs and would still receive funding from the new government. By 1994, the semi-completed prototype was transferred to Zhukovsky Airport to perform ground testing and high-speed ground tests. Alas, a lack of progress and the government breathing down their necks, the program would come to a full stop. There was simply not enough money. The engineers didn't even have enough to buy wiring to complete the prototype. In an effort to get back on track, MiG decided to scrap their LFI development plans to try and secure funding for the MFI. But this wasn't enough. The Bureau even begged the military and government officials to let them show the aircraft to the world, with a hope that with its performance at an international airshow, possible foreign investors like India or Arab countries would jump in to fix the funding shortfall. But they were refused time and time again. After waiting 3 years with no money and no support, the government finally cancelled the production of the fighter in 1997. But surprisingly, this was not the end of the program. You see, it would actually be their rival Sukhoi who would come to the rescue in a roundabout way. They had their own jet fighter cancelled many years ago, but decided to stick it to the new government and build it anyway. Sukhoi would surprise everybody with their Su-47 reveal in 1997, a jet that they financed themselves and built it despite the government shutdown. So now MiG was adamant to continue at all costs, no matter the expense, and not let this project fail, or be a loser to Sukhoi. After finally admitting that the project existed in 1998, and many changes in the actual management of the MiG Bureau, the development continued. Well, sort of.
By the year 2000, the Izdalia 144, or better known as the MiG-144, finally took to the skies with the hero of Russia, test pilot Vladimir Gorbunov, behind the controls.
In his words, the aircraft performed very well and the second, longer flight soon followed, so there was still hope for this program. Except that there wasn't, for you see, the whole thing was too late. There are a couple of reasons behind the complete failure of the MFI program and the MiG-144 as the aircraft. The first was very simple. The first flight occurred 10 years after its counterpart. By the time Raptors were in operational service, the MiG was just testing basic flight performance. They were looking at another 10 or so years to put this aircraft into operational service, and by then, it would be completely obsolete. The second reason was the obvious one: money. But not just the lack of funding, but also the unit cost. MiG projected that the unit cost for this jet would be around $70 million US, compared to around $71 million for the F-22 at the time. This was a completely unacceptable embarrassment for the fragile Russian economy and led to an easy choice to cancel the project. After all, nobody can buy it if they can't afford it. The third and final fact was that the MiG Bureau was going through a very rough phase. Many corruption scandals, slow international sales, and not enough work from the Russian Air Force, and even the legendary test pilot left the company, and he was to be the lead pilot for the program. It seemed like MiG sacrificed everything to build this 144, and it was an empty shell by the end of it.
In the end, a new program was opened called the PACFA, and the Sukhoi was chosen without any competition as a bureau to work on the project because of its financial stability, great sales performance, and successful development of the Flanker family.
Everything the MiG Bureau wasn't. Also, the Su-47 was developed completely on their own budget and without government funds, and was far more successful than the ill-fated MiG-144. This was also the moment which marked the start of the inevitable end for the legendary Mikoyan and Guryevich Bureau, which merged with a few other Russian bureaus into the UAC, or United Aircraft Corporation, in 2006. New programs like the MiG-41, which you can check out here on the channel, leave some light at the end of the tunnel for the company, but just as we've seen recently, the final end to the LMFS project and the birth of yet another Sukhoi, the Su-75 Checkmate, this is doubtful. For a long time, the only flying prototype of the MiG-144 was rotting on the tarmac of the Zhukovsky airport, but it was refurbished and displayed at the Max Air Show in 2015, with a hope for a future in the museum, because it is undoubtedly a big part of the rich Soviet and Russian aviation history.
Hope you enjoyed this video, and please check out my channel for many other Russian projects from the 90s linked to this one, like the Su-47 or the upcoming video about a naval version of this jet, the mysterious S-22. See you soon! In 1997, a revolutionary aircraft took to the skies above Russia, and its wings were the wrong way round. Now, forward-swept wing design wasn't something new, but this might have been the first time that it actually worked. Sukhoi envisioned this to be the future of the Russian Air Force, and more importantly, beat their rivals MiG in the race for the 5th gen jet. Today we're going to explore the story, the hardship, and the engineer's vision behind the jet of tomorrow, the Su-47 Rakut. During the 80s, the Soviet Navy had big dreams to conquer the seas, defend the vast Russian coast, and to rival the American Navy power. But to do that, they needed a new state-of-the-art jet. Sukhoi developed a new aircraft named the S-22 and actually dubbed it the Su-27KM to confuse the West. It would be Russia's 5th generation air dominance fighter for the Navy to accompany the Yak-141, a lighter VTOL-capable aircraft. And you bet there's a future video coming for that as well. Up until recently, not much was known about the project, but there was actually a mock-up made at the time, including a very interesting flat exhaust nozzle design choice. But then a change had come for the USSR before Sukhoi could build a prototype, and there were no more fat paychecks to spend on crazy projects. However, Sukhoi Bureau started seeing potential and saved this design and thought that it could be their opportunity to finally beat their rival MiG and reserve their spot in the 5th gen race. But ironically, the tale as old as time doesn't actually start with Russia. The story behind the S-47 and the forward-swept wing design leads back, like nearly all aerospace projects, to the Third Reich. In 1944, the Nazis built a new jet bomber which could outrun enemy fighters at the time, hoping to somehow change the tide of war. It was called the Junkers U-287. The main issue was the amount of stress that was put on the wings, both in terms of bending and twisting during flight. Without composite materials that we have today, the project was doomed from the start, and other advantages of this wing design, like reduced drag and increased maximum speed, couldn't be utilized. But the Allies, including the Russians, took notice, and once an idea is created, it's hard to shake, and it would be the Americans who would finally get this experimental design to work. In 1984, Grumman started an ambitious project on an aircraft called the X-29, and it was a joint NASA and US Air Force project to test the capabilities of forward-swept wing designs for future fighter jets. This time, they would use composite materials like carbon fiber that would be light enough and strong enough to finally allow a real forward-swept wing design to be built. The Russians had been working on a design like this for a very long time, longer than you might think, since World War II with the DBLK, but finally there was a solution available: Around the same time of the Grumman experimental aircraft in the late 80s, the Soviets started two very ambitious programs called the MFI and the LFI. Their task was to create a new multi-role fighter and a light fighter to counter the US's ATF and future JTF programs, which by this point I've covered pretty well on the channel. The famous MiG Bureau won the contract to create a multi-role fighter prototype, which then turned out as the MiG-144. But the Sukhoi had an ace up their sleeve and a vision to follow, and they were not going to give up that contract that easy. They said, if you won't fund the forward swept wing jet, we'll do it ourselves. The leadership of the Sukhoi Bureau decided that they would fund their project internally and beat MiG at its own game, letting the more superior jet aircraft do the talking. Now, this would be a huge gamble on the future of the company, not seen in aviation since Boeing gambled with the creation of the 707, and like Americans, they would build a full prototype first. The aircraft was redesignated as the S-37, and they got to work. By 1997, it was ready to take to the skies. So now let's talk about the most futuristic and most powerful jet the Russians might have ever created. And boy, the engineers went crazy with this aircraft, just like Homer Simpson when he designed his own car. Like the X-29, the flaw of the forward wings were solved with the use of carbon fiber and composite materials. The wings of the Su-47 were around 90% made out of composite materials and allowed the aircraft to have a fighter performance with better fuel consumption because of the lower drag. Large canards were mounted in the front of the wings to help the pilot steer and maneuver the aircraft, and unlike the X-29, the Su-47 was a powerful bird with two Soloviev D-30 F6 engines, providing 93.1 kilonewtons of thrust, each with either 2 or 3D thrust vectoring nozzles. The same engines that were used for the MiG-31, and we know how fast that thing was. This would allow for a max speed of over Mach 2.2 and give the plane the same maneuverability as the Su-35 or F-22, pulling more than 9 Gs without structural damage. The weapons bay was also interesting. Unlike the F-22 or F-35, or even its successor, the Su-57, the one of the Su-47 had a rotating launcher with new R-77 missiles, similar to how cruise missiles are carried on bombers. It would be able to carry additional fuel tanks or go air-to-ground weaponry on a minimum of 2 hardpoints on the wings. It would also have a 30mm cannon that would complement the other weaponry to make it the ultimate air superiority machine. Air ducts were S-shaped to further decrease radar signature, and although we couldn't say that it would be as stealthy as the Raptor, for sure it would have had a slightly decreased RCS compared to 4th gen aircraft. The two tail booms bring up the rear of the aircraft that housed ECM equipment because it couldn't be located on the tips of the wings as traditionally on modern flankers. Some parts, like the landing gear, was actually borrowed from the Su-27 family to cut down production costs, because remember, they were paying for this themselves. But it featured a glass cockpit and steering controls were on the sides, like with the Su-37, which is actually quite uncommon for the Russian aircraft. So in 1997, with this incredible machine built, the Golden Eagle performed its first flight. If it was so superior, why didn't the Russians use it? The jet first went on display to the public at the Max Air Show in 1999. Supersonic tests were completed during the year 2000, and the plane became a testbed for all the new technologies that were developed for a new age of Russian fighters. Initially, it was limited to Mach 1.6, but some sources say that speeds over Mach 2 were achieved with the jet. However, issues with the wings started to plague the aircraft at such speeds, and it was yet another problem to solve with a very limited budget at hand. And in 2001, it was finally redesignated from the S-37 to the Su-47 Berkut. By 2002, over 150 test flights had been carried out to complete various tasks and gather other data, and by this time all the effort that the Bureau had put into the project had finally paid off. After many delays and problems, the MiG-144 was cancelled along with the MFI and LFI programs back in the year 2000, and a new program called the PAC-FA was started, with Sukhoi being chosen as the contractor because of its success, further developments of the Su-27, financial stability and exports. But the critical factor was the success with the development of the experimental platform such as the Su-47. But as we know today, the PAC-FA program didn't actually choose the Su-47. Why? The government decided to further push the development of the Su-35 based on the Su-37's experiences and make it Russia's new 4++ Gen Air Superiority Fighter, as they were working on a new stealth aircraft to enter service, and there were also some budget cuts prolonged by the development of the PAC-FA over many years. The Berkut actually flew for a couple more years, being a testbed for many different technologies, avionics, radars, EW systems, etc. And by the time the Sukhoi finally got the funding and green light from the government for the PAC-FA program, the design was already outdated and obsolete, and they needed to base their new 5th gen fighter around something more familiar and future-proof. This led to the Su-57 with a more traditional stealth design inspired by the YF-23 and F-22 Raptor, but it was the Su-47 that made it possible for this aircraft to enter serial production and become the first Russian operational stealth fighter in history. In 2009, the legendary Su-47 was finally displayed to the public again, now being a legacy and a testament to the willpower of the engineers and test pilots working for Sukhoi during the 90s and pushing through all the hardships to beat MiG and write the modern history of the Russian Air Force. And there you have it. Maybe it was too complicated and maybe it could never work, but we can definitely say that this one was a win, at least for Sukhoi, and many of us aviation enthusiasts. This was always that design that we would go back to admire and even fear because of its sleek but dangerous look. Thanks for watching, and do svidaniya. This is one of the most controversial jets ever built. Not only is it the result of more than a decade of development and the successor to the legendary Flanker, but the West already claim it's just a copycat. It's a 5th generation state-of-the-art Russian stealth jet that apparently isn't stealth, and it's the future of the Russian Air Force, but they haven't managed to build more than 24. Controversial indeed. But it's possible that this aircraft is more than just a fluke. Is it just all Western propaganda? Or is it really a future dangerous underestimation of an adversary? Today, let's explore the history, the myths, and the truth behind the future of the Russian Air Force and their attempt at a stealth fighter, the felon from the East, the Su-57. In the 1980s, there was one type of new aircraft that was hot, and that was a stealth plane. The Americans took this in their stride and developed the ATF program that led to what we know today as the F-22 Raptor. But what if I told you that the F-22 Raptor isn't actually a stealth jet? Contrary to popular belief, stealth doesn't mean invisible to the radar. It means that the enemy radar, either an aircraft or on the ground, won't be able to detect and achieve a lock on the target in time. And this is the key word. The B-2 was designed as a bomber that would be able to slip between Soviet air defenses, limiting their range, and the F-22 Raptor was designed as a first strike air dominance fighter. that could secure the airspace before the enemy could get missile lock. But the Russians, when encountering this technology, had other things in mind. They believed that the aircraft should have a higher performance first and stealth second. This led to their 5th gen jet program called the MFI, which was aimed at a high performance aircraft with some degree of radar cross-section minimization. It eventually gave birth to the MiG-144, which failed miserably, due to Russia as a whole failing miserably in the 90s. But the rejection in the MFI program led the Sukhoi Bureau to put their money where their mouth was and make their own futuristic fighter called the S-37 Berku. This self-funded aircraft aimed to become a technological demonstrator for the ideal future of the Russian Air Force and show the powers in charge what they could do. You know, the famous forward-swept wing design we all flew in Ace Combat. And this inspired the nation to try again. The Russian government, after the failure of the MFI program in the early 2000s, started a new program called the PAC-FA, or Prospective Air Force Complex of Fighter Aviation. Yes, it's a very weird name, I know. Sukhoi was chosen without competition because they had the experience, proved to be able to develop a prototype with their own funding due to good export performance in the 90s and 2000s, and well, that the MiG's future wasn't really that bright. And Sukhoi, seeing all the drama around the F-22 being a stealth fighter, wanted to give it a good hot crack. And this is where the story of the Su-57 begins. For years, the new Russian 5th gen fighter was under the veil of secrecy and the main topic of discussion on forums, military blogs, and in the news. But in 2010, we finally saw the first pictures and the first videos of this new fighter called the T-50 taking off from the airfield and performing its first flight. The media went crazy, saying it's just an F-22 copycat, that it's so bad it's good, but the truth is that it was somewhere in between. So I'm going to show you exactly why the Su-57 was a beast of its own. And let's start with the obvious comparison. The Su-57 does follow the wing design of the American 5th gen fighters, but this is where the similarities actually stop. Unlike the F-22 or F-35, the Su-57 follows the similar design of flankers, with engines located in gondolas and a tunnel between them to increase the maneuverability and lift performance. The vertical stabilizers of the Su-57 are canted, which is the main requirement of any stealth aircraft to minimize its radar return, but they're also used as a whole as a control surface, similar to the YF-23 design. Yes, that's right, the rejected YF-23 that the Americans didn't choose when they were looking at the F-22 program. And it's this jet that the Su-57 is actually much more inspired by than the Raptor. The nose section closely resembles not just the YF-23, but much more the NATF-23 concept, which was based off the YF-23 prototype, and we've done a whole video on the channel about this crazy Navy variant. The Su-57 kept the horizontal stabilizers and added LERX control surfaces, or leading edge root extensions, which can be used as sort of canards in flight, again with maneuverability top of mind. But this is where it gets a little weird. From the first prototype onwards, one notable design choice was the regular thrust vectoring nozzles and exposed titanium of its AL-41 engines. But I'll get back to why that's weird later. Another problem with the engine placement is the not fully hidden compressor blades inside the S ducts, even though the Su-47 had them hidden. Speculations about the actual stealth performance of the Su-57 started to flare up right away, with some people questioning that this design was even remotely comparable to the F-35 or the F-22 when it came to stealth. So let's squash that bug right now.
The kind people at Aircraft 101 did an amazing work to settle the question of stealth once and for all. They created some highly detailed 3D models of some famous modern aircraft and then used mathematical model and radar scattering simulations to get the data of radar cross-sections over the wide range of frequencies. Meanwhile, a leaked document for the Su-57 stealth design patent actually stated that it has an RCS of 0.1 to 1 meter squared. This is much more than the F-35's 0.00015 or the F-22's 0.0001 meter squared, meaning that the Russian jet has the stealth characteristics of a brick wall. These numbers proved correct, however, there was a caveat. And trust me, we're about to get really technical, but it's the devil in the details. If we were to examine the results from the Aircraft 101, which does not include the effect of RAM materials, which can't be calculated with precision, the Su-57 has a median radar cross-section of 0.48 meters squared in a frontal 120 degrees. This coincides with the Russians' leaked report. However, an F-35's median RCS stands at 0.06 meters squared. So if we take a look at the diagram, it shows a very slight angle of which the F-35's radar cross-section drops to negative 35 or 0.0001 meters squared. But that's the minimal RCS, not the overall frontal RCS of the aircraft. So if you take into account the addition of RAM materials, and this paper on RAM material simulations can decrease the radar cross-section up to 90% when the whole object is covered in these materials. But here's the thing, the F-35 or any other jet is not covered in these materials. They only use it on the hatches or important sections where the radar waves might scatter back to the source. So a decrease in the median RCS can go anywhere between 20 to 90%, but not the 200 or 1000% that people have claimed. The bottom line is that there's no chance that the Su-57 can match the stealth characteristics of the F-35s or F-22s, but it's not as far for them as the media wants you to believe. Any modern radar would have trouble detecting and tracking a sub 1 meter squared target, so in the eyes of the Russians, it's stealthy enough. Although I do want to just draw back to those strangely exposed engines. On the side or back section of the Su-57, the radar cross-section is probably much higher than its American counterparts because of those engine issues. And then of course we have the famous exposed screws with the Su-57, but this is not a key factor because, well, as you could see, both the F-35 and F-22 also have exposed screws, and they are both still extremely stealthy aircraft. But it's the stealth that isn't the biggest issue with the Su-57, it's actually those engines. The Russians made the same mistake that put to trash so many projects throughout the Cold War. They started development of this jet without its new engines. Now that's not really a bad idea per se. I mean, the Rafale and the Su-27 and many other successful jets flew their first flight without engines designed for them, but that was a flaw that was quickly fixed. The Su-57 on the other hand still doesn't have its proper engines. The development of Isdalia 30 is a long and still not concluded story, and the serial production of the Su-57s fly with AL-41F1 engines similar to the ones used on the Su-35. And these are great engines, don't get me wrong. However, even though they are designed as Super Cruise capable engines for the MFI program, the ones inside the original Su-57 are not based on the original AL-41Fs because they were too large for the Phelon, and instead they're based on the older AL-31s, meaning the Su-57 might not be able to achieve Super Cruise in a full combat load, as the Su-35 can only achieve it in a light configuration. Yikes. Now the cool thing is about these AL-47s is that they have 3D thrust vectoring, giving the Su-57 amazing maneuverability, as well as the thrust to weight ratio over 1 with combat load, making it a beast for dogfighting. But this isn't the era of dogfighting, and this scenario is highly unlikely in modern combat. Sorry, Tom Cruise. The new Asdalia 30 or AL-51 engines are supposed to have the supercruisability at Mach 1.5, serrated nozzles like the F135 engine on the F-35, and the ability to eliminate the exposed titanium area and maybe even more flat, more stealthy design as seen on the S-70 drone. But when exactly that's going to happen remains to be seen. Oh, you didn't know this aircraft comes with its own drones? This is where it gets really cool. What could really give the edge to the Su-57 is the use of a wingman-style drones such as the S-70. And unlike the Su-57 with all of its issues, the S-70 is much more designed with stealth in mind, and its size gives it the ability to carry some serious ordnance. Paired with the Su-57, it could be the perfect protection or attacking force, where a Su-57 or an AWACS aircraft could spot the targets for the drones and let them go forward so they can gauge with the enemy completely unseen. Along with these drones and their Su-57, Russia is also developing something called the OSNOD, a new data link system, the equivalent to the Link 16 in NATO, that would allow for such military drone operations. The S-70 has already performed several test flights and is deep in the development phase, so it's not a paper project. But the war in Ukraine and the state of the Russian armed forces afterwards begs the question, where exactly are they going to find the money to fund all of these prospective but far-fetched projects? So it's taken me 13 minutes into today's video to get to the real issue with this project: money. Originally, India partnered up with Russia in 2007 to help finance the development of the new fighter, in return to get their own two-seater variant and the license to build this new jet at home. The development of the T-50 prototype and the PACFAR program as a whole suffered numerous delays and issues due to the engine and the completely new avionics with the radar, sensors, etc. that was supposed to go into this aircraft. And so the Indians, rightly so, got fed up with it in 2018. They exited the project with the option to buy a finished aircraft in future if Russia ever got around to mass producing it and it entered service within the Russian Air Force. But this is where it gets dicey. Russia dropped their initial plan of 200 of these fighters all the way just to one squadron of 12. Talk about a decrease. But this was soon changed with the first contract for 76 aircraft being signed in 2017. But this delivery has been extremely slow, and so far only around 10 plus airframes are in operational service. The Su-57 was allegedly used both in Syria for testing and in the war in Ukraine in an air-to-air battle, and even apparently scored a kill against a Ukrainian Su-27. But all of that is in the realm or might have not, and because this war is a fully fledged battle of propaganda from day one, spinning a yarn that the Su-57 was an amazing aircraft in the heat of battle would be an incredibly successful image for Russian customers. So again, that's me telling you to take this all with a grain of salt. Now to answer the very big question that's on your mind: what would exactly happen if the Su-57 went toe-to-toe with America's best, the F-22 Raptor, or perhaps the F-35? Well, I hope you're strapped in, because we're gonna go into the real nitty and gritty detail, and we'll start with its electronics and weaponry. The Su-57 is equipped with the new AESA radar called the N036 Beleka, which is actually made up of 5 different antennas. The main antenna operates in the X-band and it is used to lock onto enemy targets and engage, as well as detect enemies on long distances. There are 2 side antennas that also operate in the X-band, but with a shorter range, giving the aircraft much better coverage around 270 degrees. And there's another 2 antennas on the wings that are operating in the lower L-band frequency, and they're used as part of the electronic warfare system. Yes, that's right, this aircraft is digital. At the front of the canopy is a system called the IRST, which allows for detection of thermal signatures of enemy aircraft and the use of IR-guided missiles without using the radar. It's the same as the one of the EOTS functions on the F-35 and something that the F-22 Raptor lacks, but it might get it in an upgrade soon. Now, the Su-57 does have sensor fusion and a computer working on all of the collected data to give situational awareness to the pilot, similar to the DAS on the F-35, but it is certainly inferior to the unparalleled situational awareness that the F-35 pilot has with that amazing helmet and DAS system. One big issue of the Su-57 is the lack of an interrogated targeting pod like the F-35. The F-35, on the other hand, can use its internal systems for targeting ground-based targets, so it still remains stealthy. To sum it all up, the Su-57 is quite capable platform with some issues which place it behind its Western counterparts in some aspects, but it is way beyond any 4th or 4th plus gen aircraft in the market and any 5th gen fighter development as well, so it's truly something to be reckoned with. But what about the future of this program? As we explained in the video, the Su-57, although not perfect, still has a very powerful radar and avionics, decent stealth capability, and great engines. Well, sometime soon if they come along. The planned Su-57M update will feature them, at least because drones and other stuff is still in the sci-fi domain, to be honest. But neither of these Western jets would be able to detect the Su-57 in time if they're in combat, because it's also capable of carrying the R-37M long-range missiles and firing them from at least 200 kilometers away. Russia plans to use the Su-57 as a team leader of several jets to provide surveillance and support in combat. Although all of this is very nice in theory, the issue is there is only about 10 to 15 Su-57s built. Even with that whole first batch of 76 delivered, that's not enough to counter even the single F-22 fleet, and definitely not the 1,000 strong F-35 fleet in both the US and NATO. Ironically, all of this discussion about who would win makes me think that we're looking in the wrong direction. The Chinese J-20 is a way bigger threat to the US because it is actually in serial production, unlike the Su-57. And given the state of the Russian armed forces in Ukraine right now, time will tell. For all we know that this is one hell of a good-looking bird, and that its claim of being a stealth aircraft is as real as those engines. And even though some people say that it's obsolete, I think that this aircraft, along with the F-22 design, will shape many future aircraft and maybe even whole generations to come. I hope you guys and that one girl enjoyed this video, and I hope to see you soon in the next episode of Found and Explained. Meet the new jet that has America very afraid. Able to fly further than the F-35, reach Mach 1.8 without afterburners, and can even be remotely controlled by an AI pilot. On paper, this new concept stealth jet is deliciously impressive. On paper, that is. As many might know, the journey from concept to creation is filled with turbulence. Is this jet the future of Russia's Air Force, ready to go toe-to-toe with the best of the USA, or an experimental dead end? It's time to reset the board as the Su-75 has made it checkmate. The Cold War of the 20th century between the United States and the then Soviet Union might be over, but a 21st century arms race continues at full speed ahead between the United States and the Russian Federation. The latter, now depleted of all its former Soviet republics, continues to be a thorn in the side of America's military aviation industry and its allies. It's not by chance that Russia continues to use its famous May Day celebrations to show off its military might and hardware, such as the Soviets did back during the USSR days. Like any military power, Russia makes big song and dance of the unveiling of any new aircraft. Such was the case with its new fighter jet that many aviation experts believe will be a direct competitor to the US's F-35 superiority fighter. The plane comes with not one but two catchy nicknames, namely the Sukhoi LTS Screamer or the LTS Sukhoi Checkmate. The Russians, rather wirily, refer to it simply as the Checkmate. Let's not forget that Russians are chess masters bar none, so a plane dubbed that does command some of my attention. Let's get the obvious out of the way first. Many have noted how the Sukhoi LTS Checkmate looks a lot like the Lockheed Martin-made F-35 stealth fighter. Similarities between Russia's Checkmate and America's F-35 are particularly stark design-wise. For example, like the F-35, the Russian Checkmate includes widely splayed split-angled tails, a narrow fuselage that houses a single engine, and large wings that are somewhat diamond-shaped. However, rather than being a case of Checkmate being a copy of the F-35, these similarities shouldn't be too surprising. After all, any stealth aircraft is fundamentally constrained by the aerodynamic limitations imposed by having stealth features. One can only defy physics so much. Further design features of the Checkmate include its cropped delta wing and movable fins that act as ruddervators, which provide control on both the pitch and yaw axes. Sharp-eyed analysts felt its most striking feature is its intake, designed as a chin inlet slung under and wrapped around the lower fuselage, but with a still flat underside. The size of its wings suggests that the plane could climb to 40,000 feet or higher, but of course, being a secret project, we don't know yet for sure. Weapons bays for two short-range air-to-air missiles are found on either side of the fuselage, and a capacity for 3 longer-range weapons carried in the lower bay, as well as an internal gun. The Checkmate can also carry weapons on the external pylons for missions not requiring stealth, with the internal weapons bay is designed to carry both air-to-air and air-to-ground ordnance, including both infrared, radar-guided air-to-air, air-to-ground and anti-ship missiles, guided and unguided bombs, and unguided rockets. So it's pretty easy to say that this aircraft has weapons to spare. In terms of weight, the plane's maximum combat load is 7.4 tons, which includes a range of air-to-surface weaponry with a maximum takeoff weight, or MTOW, of approximately 18 tons. As for speed, there are claims that the plane can reach Mach 1.8 and fly supersonically without the use of an afterburner, with an 8G maneuvering rate. Its power plant would probably be the same engine used to power the Su-57 twinjet. Other features of the plane heralded by the builders, Rostec, include that it will feature artificial intelligence, or AI, in some capacity. Although to what extent and to what end that AI will be used in the aircraft remains, for now, unknown. However, AI will no doubt be used for the plane's voice control technology. Speaking of AI, a spokesperson has also said that both a twin-seat manned version and an unmanned version of the Checkmate are being considered for development, leaving us to wonder if the future of Russia's Air Force will be metal pilots. It's being commentated that the launch of the new Sukhoi LTS Checkmate was probably the loudest way to announce a new stealth aircraft. Every year, Russia hosts what is called the MAKS show, standing for the International Aviation and Space Show, which is an air show held at the Zhukovsky International Airport. Various Tupolev, Ilyushin and other planes, both military and commercial, have been tested at the airport, and its place in the sordid history of Russian aviation and space exploration makes it an ideal venue for this event. In attendance at the 2021 show were 831 companies from 56 countries. So what I'm getting at is that this is the show for Russian aviation. And it was at this event on July 20th, 2021 that the new Russian jet was unveiled with much pomp and very loud music. The plane is designed by Rostec, a defense giant that is a subsidiary of the Russian conglomerate, United Aircraft Corporation. According to the Associated Press, Rostec boasted about its new aircraft prior to the July 20th launch as being a fundamentally new military aircraft, and further stated how it had been produced in what they call one of the few countries in the world with a full cycle capacity for producing advanced aircraft systems, as well as recognized trendsetter in the creation of combat aircraft. As an interesting side note, this same company did also announce hydrogen-powered engines for both aviation and ground applications, which I think we can agree needs its own video. Yet while it might be easy to show off a new fighter jet concept, can Russia actually afford this new creation? It's worth noting that jets with twin engines, such as America's F-22 or Russia's Su-57, may allow for greater speed and reliability, but they're also much more expensive and heavier, which in turn means that they're more thirsty for fuel. Twin-engine fighter jets also tend to be more complex and thus expensive in terms of maintenance. So a single-engine jet such as the Checkmate should be less expensive in terms of purchase, fuel, and maintenance costs. Nevertheless, it doesn't mean that Checkmate is a cheap plane. According to the CEO of the project, a Checkmate will set back a buyer around 25 to 30 million. However, and this is of critical importance in the global aviation stakes, the Checkmate is a lot cheaper than the F-35, which was selling around 78 million a jet as of 2020. Far more countries worldwide will be able to spend around 30 million for a fighter jet than the mere handful that can afford to fork out the 78 million per F-35 bought from America. So you can start to see that the economics make sense. It is known that should the Checkmate be produced, the Russians will be depending heavily on foreign sales to make the plane financially viable. And that brings us back to the launch party and explains why they had such a flashy big event and had a video released on YouTube to promote the Checkmate prior to its launch, featuring pilots from the air forces of potential client countries such as the United Arab Emirates, India, Vietnam, and Argentina. Those are the types of countries that the Russians will be betting will want to buy their own Sukhoi LTS Checkmate for their Air Force collections. A further boost to the sales of the Checkmate could be that the new plane has a planned combat radius of 930 miles, or 1,496 kilometers, which is about 250 miles or 402 kilometers farther than the F-35 can travel at its least heavy weight. It's true that external fuel tanks can increase the range of the F-35, but that makes the plane less stealthy, and that, in turn, means that the Checkmate would essentially be in a class of its own when it comes to stealth fighter jets. So perhaps cost will be the ultimate checkmate move of the Sukhoi LTS. Not surprisingly, many Western aviation pundits were quick to point out that the Sukhoi LTS is only a prototype, potentially far from being mass-produced fighter jet ready for international sales. Experts at the show noted a lack of wiring and hydraulic lines within the visible parts of the main landing gear, and other telltale signs that indicated what was being launched was only a mock-up rather than an actual flight-ready aircraft. However, it's worth mentioning that Rostec themselves have confidently claimed that the Checkmate will be ready soon for test flights. Whether that was actually true or merely wishful thinking by the Russian aviation company is yet to be known.
Rostec remains confident that the Checkmate's first flight is scheduled for 2023, with deliveries earmarked to clients by 2027. But some critics have been quick to mention that the F-35 itself took nearly 2 decades between its concept and production. But using the F-35 as a yardstick is just about the worst analogy possible, given that aircraft's farcical history. In fact, for the sake of context, let's take a quick step back in time to look at the F-35 project. The Pentagon had decided to replace the very successful yet aging F-16 fighter, of which 4,600 had then been built by General Dynamics since the mid-1970s. And the F-16 was a great jet. It was super easy to operate, easy to maintain, and could fly at twice the speed of sound, carrying 15 different bombs, including 2 nuclear weapons. It could do even more, shoot down enemy aircraft with 5 different varieties of air-to-air missiles, and wipe out ground targets with 4 different air-to-ground missiles. It was a super versatile, all-out killing machine. And then came along, or rather blundered in, is the F-35. The F-35 cannot fly at twice the speed of sound. In fact, its supersonic flight mode on the control panel carries an ominous warning for emergency use only. The F-35 designers also opted for touchscreen switches, rather than the usual toggles or rocker switches that pilots usually use. A very well and modern dandy, except that touchscreen switches don't function 20% of the time, which is somewhat problematic for fighter pilots in the middle of a dogfight. The list of flaws on the F-35 goes on and on, including the heat coating on its engine rotor blades failing so often that literally 5 to 6% of the entire worldwide F-35 fleet is grounded due to safety concerns at any one time. Even more scary is the bubble shield of the fighter jet that starts to delaminate in mid-flight, which is beyond dangerous. The development of the F-35 has been an unmitigated disaster, which is why even a prototype Russian stealth fighter jet, even if far from being ready for production, is still a big worry to the bigwigs at the Pentagon. As noted, Rostec has set itself the deadline of 2023 for the first test flight and 2027 for rollout of the Sukhoi LTS Checkmate. Any aviation expert will tell you that these are highly ambitious target dates for a plane of this magnitude and cost. However, there is no denying that the Russian plane has some strong selling points, most notably its relatively low cost as a stealth fighter jet. Whether the Sukhoi LTS will achieve a checkmate in its aviation class is yet to be seen. This is the ultimate attack helicopter, a true masterpiece. Well, it was supposed to be. With double the rotors and firepower to match, this aircraft is considered among many to be the final evolution of the perfect modern-day cavalry. Built as the answer to the legendary Apache, it promised so much for the Soviet Air Force and allowed Kharmov to finally prove itself as the true innovation giant of the Soviet aircraft industry, despite rival Mil stabbing them in the back. However, while the Ka-52 ended up doing exactly what it was made for, fighting American-made armor, its very high loss rate in Ukraine, operational problems, and ridicule in the media have made it anything but. This is the most controversial helicopter flying today, an engineering miracle of flight, desperately holding on to its crown. It's the early 80s, music is still great, Indiana Jones is in the cinemas, and on the tarmac of the Kharmov Bureau's test facility, a new concept helicopter is taking to the skies for the first time. The main Soviet attack helicopter during the 70s was the Mi-24, also known as the Crocodile, but it was not a dedicated attack helicopter, rather a transport attack helicopter hybrid, and when Hughes unveiled their AH-64 in 1975, a specialized anti-armor helicopter, the Soviets realized that they had some work to do. You see, the Americans had gone in a completely different direction with the AH-64 design, radically different from the Cobra that had come before. It was powered with two engines to increase power and survivability, and they were positioned on each side of the fuselage. The Russians' Mi-24 on the other hand, although a twin-engine helicopter much the same, had its engines positioned next to each other on top of the cargo compartment. And hitting one in combat meant that the other one was likely to be damaged as well. Thus, the desperate Soviets started a new attack heli program in the early 70s, but it was dormant until the new threat was revealed from the West. The usual suspects, Kharmov and the Mil Design Bureaus, started to work on an answer to the American Apache. Mil, with a pedigree and several very successful projects so far under their belt, had the upper hand and went with a very similar design to the Apache, a twin-seater with separate engines and anti-tank weaponry. But Kharmov realized that their only chance of winning the contract would be to come up with something completely different. They started by pulling out their already developed coaxial rotor designs for their Navy helicopters like the Ka-52 and proposed something similar. Now, you're probably wondering what exactly is so special about a coaxial rotor anyway? Well, in a traditional design, as the rotor spins on a helicopter and creates lift, a counterforce pushes the whole fuselage in the other direction, and that's why a tail rotor is introduced as a means to counter that force in the opposite movement and stabilize the aircraft. As the lift is generated, the engines provide further thrust to move the aircraft in any direction. So now you understand that if the tail rotor is damaged, helicopters generally enter an uncontrollable spin and is doomed to crash. Now the twin main rotor, or the coaxial rotor design, has its rotors spinning in opposite directions, eliminating the counterforce that pushes the fuselage. Also eliminated the need for a tail rotor, and in case of even losing the whole tail surface, a helicopter can still land safely. Something that is going to come back in a big way by the end of the video. But apart from that, the twin rotors also create more lift and allow for much better maneuverability in flight. But Kharmov didn't stop there. This was supposed to be the ultimate attack helicopter after all. In the words of chief designer Sergei Mikheyev, the most expensive part of the helicopter is, well, the pilot. Therefore, the new V-80 only had one pilot because they needed to spare on experience. But exactly this choice will come back to haunt this project some 15 years later and almost cancel the whole design. However, not only did they try to minimize the casualties in case of losing a helicopter, it was also equipped with an ejection seat, which was a novelty in the helicopter world, although a standard in the world of aviation by that point. It was one of the other rare Soviet projects where everything was survivability and pilot-oriented. This new helicopter was envisioned not only as an attack helicopter, but also as a portable anti-air system, because it was equipped with short-range anti-air missiles and was to provide support against enemy helicopters and low-flying planes on the battlefield. Which, if you think about, is totally insane to see a helicopter go up against jets. But this actually makes sense in a way, because a helicopter would be very hard for enemy jets to target on longer distances. But with time, the design changed and the focus was moved towards a classic attack helicopter role with a specialization in anti-armor tactics. New Hellfire missiles developed in the mid-80s pushed the Soviets towards development of a similar weapon too. And thus in 1990, Kharmov was green-lighted by the government and the first batch of helicopters was being built. But in most of our stories that take place in this era, this little key event happened in 1991. That's right, the collapse of the USSR. Picking up from the ashes in 1992, the now new Russia presented the new attack helicopter to the world at an airshow in England. Officially called the Ka-50, this new aircraft soon got a nickname, the Black Shark, for its mean looks and black paint job. It presented itself as the next generation of attack helicopters with extreme maneuverability and survivability, overshadowing a fancy piece of weaponry which was also critical for this program to succeed, called the 9K121 Sukhoi missiles. And boy, I have to tell you just how great these laser-guided missiles were. They had a range up to 12 kilometers, and paired with the new automated targeting system, they would be a perfect weapon against armor. These missiles were also part of the Su-25T, a tank killer upgrade, which we mentioned before in our Su-25 video. After the pilot finds a target, they would just have to mark it with their eyesight and launch a missile. Targeting, guiding, and everything else was automated and require no further input from the pilot. This would mean that both the Su-25T and the Ka-50 would be a single-seater and still not have to have another pilot. This development was so good that just 1 year later, the Mi-28 was cancelled by the Russian government because it was deemed inferior to the Ka-50, as well as lacking the radar and ability to fly missions during the night and in bad weather conditions. It seemed for Kamov and the Ka-50, it was well on its way to glory. During the testing phase, some issues with the design started to pop up, especially with the decision to have only one pilot. During one of the tests, the pilot was tasked with finding and destroying 25 hidden targets on the range whilst flying low and evading enemy air defenses. The Mi-28 scored 24 out of 25 hits, but the Ka-50 only scored 1. The pilot could not operate both the aircraft and the precision weaponry at the same time while performing low-level flight, and spent most of its time trying to invade the AA and not crash, and it couldn't even spot the targets. During the Chechen Wars, the Ka-50 had its first combat deployment. Fast, maneuverable, and with a state-of-the-art weaponry, it performed well, but it was still extremely hard to operate for the pilots, and it flew missions along with Ka-29s because it failed to reach the mission goals by itself. Something that didn't go unnoticed by Mil. They decided to take their previous design, the Mi-28, and thoroughly update it to the Mi-28N variant, which was presented to the Russian military again, now with radar, updated optoelectronics, and new weaponry. And soon after the war, the Russian government decided to scrap the Ka-50 program and instead buy this new Mi-28 version for the Air Force, a shocking betrayal that put Kamov on the back step. But they had one more ace up their sleeve. Back during the prototype phase, another two-seater variant was being developed for recon purposes, and to act as the command helicopter on the field, supplying data and targeting information to other helicopters. And this is exactly what the new Ka-52 would be based off. Apart from its tail rotorless design, the Ka-52 would have the new VK2500 engines that had better payload capacity, climbing speed, overall speed, and maneuverability than the American Apache. Unlike both the Apache and the Ka-50 with 4 underwing pylons for weaponry, this one would have 6. It was also equipped with a radar like the Apache D or the Longbow variant, and the Mi-28N for terrain mapping and targeting. It was also equipped with the Viability or President S missile defense system, which has a 360 degrees coverage and detects and automatically launches flares against IR guided missiles. But let's talk weapons, and this is where it gets cool. Its main weapon would be those laser guided missiles and a massive targeting recon turret below the nose section that could shoot 360 degrees. But apart from that, it also has a 30mm cannon and can also carry unguided missiles, but that's pretty standard stuff. So why has 25% of the entire fleet already been destroyed? Let's dive in to the war in Ukraine and the role of the Ka-52.
Now, this is where the discussion of the war in Ukraine gets a little bit controversial, and I want to point out the minefield that it is to talk about the performance of certain weapon systems. So I don't really want to get into the politics of the battle, but I just want to talk about the actual statistics that we have about the Ka-52, specifically how it's performed in combat. According to the OSINT list, which is obviously unfinished so far because the war is still ongoing, it is stated that out of 220 confirmed helicopter kills, 210 are Ka-52. If you take into consideration that not every missile launch or hit was published, the actual number probably goes much higher. For comparison, the US sources state that the Apaches had some 500 kills during the Gulf War, and that's without photo or video evidence. But in total, over 270 helicopters were performing combat flights, compared to a total of 120 Ka-52s in service, which are probably less than 100 performing actual combat missions. This gives a combat performance at very comparable levels to the Apache, but the huge difference is in the number of helicopters lost, so let's also talk about the elephant in the room. Out of some 125 helicopters in the Ukraine theatre, 34 have been lost to Ukrainians either in the air or on the ground. That's the same amount of Apaches the US Army lost during the 7 years of war and insurgency in Iraq from 2003 to 2010, and 15 of those were lost to hostile fire. The high attrition rates are due to several factors. First and foremost, the Russians were performing extremely poorly in the first phase of the Ukrainian war. The Ka-52, the most sophisticated and expensive helicopter in the Russian Air Force, was flying missions in the contested airspace with unguided rocket pods. Simply stupid. The Americans learnt this the hard way during the Gulf War, where during one of the attacks, out of 33 attacking Apaches, one was shot down and 30 returned with heavy damage. The Americans realized that these helicopters needed to be used much more carefully, relying on Hellfire missiles and superior mid-range attacks. It took the Russians almost a year to learn this. But let's go back to the purpose of this helicopter, its specialized anti-armor platform with a role of commanding helicopter transferring data and recon info to other units in the field. During the Ukrainian counter-offensive, the performance of the Ka-52s was put to the test, with long-range shots up to 9 kilometers away putting them out of the range of the Ukrainian anti-air systems, and being suppressed near the front lines so the Ka-52s can operate at any time. The Ka-52 is used exactly as it was envisioned, and now the losses are minimal in the past 2 months. Its defense systems are also being used to defend against rockets extremely well, but it also has some problems. Take a look at this video from Syria.
Атака слева. Гепард. Атака сзади. Роланд.
The system is informing the pilot that it's been painted by Geopard and Roland AA systems, neither of which are in operation in Syria. And there are videos where it successfully defends itself from even 2 missiles, but when the flares run out, the Ka-52 is a sitting duck, especially where there are dozens of manpads everywhere at any one time. Another issue with the Ka-52 is the strong vibrations it suffers when carrying heavy payloads, therefore restricting the amount of weapons it can carry in a single mission. This might be due to bad maintenance, wear and tear, or simply design issues that were never fixed. But last and not least, unlike Hellfire missiles or the new Russian LMURs, its current missiles are not fire and forget weapons, and the helicopter either has to maintain position or very slowly move whilst the missiles are being guided. This has led to Ukrainians shooting down Ka-52s with Stugner's PATGMs, which is something you would only imagine happening in a video game. On the other hand, ejection seats have saved pilots on several occasions, doing their job and saving them from almost certain death. Recently, we got real proof of the missing tail survivability theory. One helicopter was damaged and lost its almost whole tail section and managed to land safely. Going into the future, Russia has started to upgrade the Ka-52 with something called the Ka-52M. This modernized version will have new imaging and targeting modules under the nose, paired with a now modern AESA radar. The LMUR or Isdalia 305 missiles that we mentioned, which are currently only available for the Mi-28, will be included for the Ka-52 as well. They are true fire and forget missiles that are either passive or active guidance to the target. This new M variant is also getting new sensors and updated missile defense based off experiences during the war, and we can assume that something will be done about those vibration issues. To sum it all up, the Ka-52 weapons platform is by no means a bad helicopter. The M variant will solve a couple of problems and make it even deadlier with new weapon options. But unfortunately, we all know how it's going to be used. And on that unfortunate, depressing note, I want to thank you for watching today's video of Found and Explained. I hope that you found this video, the history and the analysis interesting, and despite all the political issues, I hope we can appreciate the hard work that the engineers made to make such an incredible flying machine. A beautiful helicopter that has an awful purpose. Flying at the edge of space at 4 times the speed of sound is a new Russian interceptor, and it is perhaps the last chance for the legendary Mikoyan and Gulovich Bureau to survive. Since the late 50s, Soviets and Russians have been developing interceptor aircraft to cover their vast territory and respond to any threats to their almost 60,000 kilometer long border. Interceptors have always had a special status within the Soviet and Russian air forces, with the legendary MiG-25 and its successor, the MiG-31, being always somewhat of a mystery and a serious threat to the West. But now the time has come for the next generation of interceptors, a new jet projected to surpass in speed and maximum altitude of even that of the legendary SR-71. This is the story of the new Russian thunder screaming across the horizon, the PAK-DP. Russia is big, and a big country has big borders. And during the Cold War, the Soviet Union found it challenging to defend and control their airspace at any one time. The US knew this defense was like Swiss cheese and developed spy planes like the U-2 and SR-71, flying missions way behind enemy lines, getting all the information and tactical advantage they needed in the Cold War. So the Soviets needed a solution. The MiG-25 was developed as an answer to the threat of US supersonic bombers and extremely high altitude flying spy planes like the U-2. But after the defection of Viktor Belenko in 1976, the US dissected and analyzed everything they wanted from the MiG-25. The Soviet Union was left holding the bag and was forced to develop a new interceptor. Thus, the MiG-31 was born and became the main interceptor of the Union, armed with long-range R-33 and then at the time, state-of-the-art R-37 missiles. Another innovation of the MiG-31 was the huge Zaslon radar, which was the first ever PESA radar mounted on a fighter jet. With its 400-kilometer range and having missiles that could hit targets up to 300 kilometers away, a maximum speed of Mach 2.8, and a service ceiling of 25 kilometers up in the sky, the MiG-31 was the perfect killing machine against any large target, either super or subsonic, trying to invade the Russian airspace. But this would be the last grand ovation for the firm. In recent years, the MiG Bureau has been experiencing failure after failure on the international market, almost stopping their aircraft production. They've had some small orders of modernized MiG-29s here and there, and a limited run of MiG-35 orders for the Russian Air Force, while focusing on modernization and maintenance of current aircraft. But all of that may change in the future, and the glorious days may yet to come for this historic firm.
During the late 80s, the MiG Design Bureau decided that something had to be done and actually started working on a new interceptor project planned to replace the legendary MiG-31 at the beginning of the 21st century. Back then, it was known simply as Izdalia 7.01 and would be the Russian jet of the future. The design was abandoned in 1991 due to a lack of funds, and instead they opted for several modifications of the MiG-31 platform throughout the years. But the engineers there at the MiG Bureau couldn't shake the idea that it was time for a new jet aircraft. During the mid-2010s, rumors had started to swirl around about a new design, but nothing was solidly revealed until 2018, when we got the first official information about a new interceptor under development. It's officially known under the fancy name of the PAC-DP, or Prospective Aviation Complex for Long-Range Interception, or internally simply known as the Izdalia 41, where the supposed MiG-41 designation comes from. However, take this all with a grain of salt, because official designations are only ever given when the aircraft actually enters active service with the Russian Air Force, and this calling card was given by the media. It's said that this plane will conceptually be based on the MiG-31, however, some of the specs are completely bonkers and questionable, one of them being a max speed up to 4.3. For comparison, the SR-71 Blackbird, the fastest military jet in history, had a maximum speed of Mach 3.3, and the engineers had to overcome huge problems with materials, heating, and aircraft construction to achieve that. Other sources, however, put the maximum speed at around Mach 3.5 for this new Russian jet, which is more reasonable, but should still present a serious challenge for the engineers. It's planned to have a slightly smaller radar cross-section than the current aircraft, or in simple words, some stealth capabilities, which will most likely make sense only from a frontal sphere of the aircraft, because the enormous engines needed to power this beast will surely make the engineers do all kinds of sacrifices to the design in order to accommodate them, and radar signature from the back or side will definitely be much larger. Everything else at this point is pure speculation, but what we can assume that it will either match or surpass the characteristics of the MiG-31 with range and service ceiling, which are 3,000 kilometers and 25,000 meters respectively. But what isn't so far-fetched is the weapons, and boy do we have something to discuss here. PAC-DP will most likely carry new long-range R-37 missiles, along with the new Coaxial hypersonic missile, which MiG-31s are also equipped with. Now, the interesting part here are the so-called satellite killer missiles, which should be also implemented with the new interceptor. Russia has been developing ASAT missiles for a long time, with the latest being the A235 Noodle, which successfully shot down an old Soviet-made satellite Cosmos 1408 in 2021. This system is made to work with the famous Don-2N radar and will be able to intercept and destroy hypersonic and ballistic nuclear missiles along with the satellites. Noodle, however, is a huge missile launched from the ground, and Russians are developing it primarily for the defense of the Moscow area. But we can say with fair certainty that the PAC-DP will be able to carry ASAT missiles, having in mind that recently MiG-31s were spotted carrying absolutely massive new missiles called Burevestnik. Possible further development of the 79 M6 contact missile. It's rumored to be an ASAT weapon working in conjunction with the satellites of the same name, which are all covered with a veil of secrecy and rarely mentioned in Russian media. And that was obviously a lot of complex Russian words, so let me know down in the description how I went, or if I should really go back to grade school.
Other than that, Russians are also looking into laser weaponry for this new interceptor, made either as missile defense or for blinding the enemy sensors and optics. A new airborne laser called Coaxial, based on the Beriv 860, has been used recently for different applications of high energy beams, and for sure both Russia and Western countries will make use of this kind of weapons into the future. Also, did you know that during the Cold War the Russians were working on an actual laser tank? That's right, and it's definitely something I want to cover in the future here on the channel. So if you like the content so far, then consider subscribing. It's fair to say that the PAC-DP would be a serious threat in the air, both in a defensive and offensive role, and with the Su-57 and PAC-DA, it would be the backbone of the new Russian Air Force. Only time will actually show us how accurate some of these claims are, if this aircraft really is faster than the SR-71. But it's great to see that no matter the reason, that aircraft engineers are really pushing the envelope for creating some of the mightiest birds in the sky. Something new is flying in the cold skies above the Arctic Circle. A stealthy flying wing armed with 12 hypersonic cruise missiles moving unnoticed towards its target. But it's not a US-made B-2 nor the new B-21 prototype. Rather, it has red stars on its wings. Strategic bomber aviation has been a long-time pride of the Soviet and Russian Air Force, and now the time has come for it to enter the new era of warfare. One where it's all about preemptive strikes, stealthy aircraft, and hit-and-run doctrine. This is the story of the first new Russian bomber after 40 years of silence. A new cutting-edge design, or just another expensive project with no future? Let's dive into the secrecy behind the PAC-DA, or as the Russians call it, the Messenger. The United States has been downsizing their bomber fleet in the recent years, with the total coming very close to the number of active bombers in the Russian Air Force. For a long time there was a wish in both the US and Russia to move on from the workhorses like the B-52 and Tu-95, two of the longest serving bombers to this day. However, instead of retiring, both are undergoing or have undergone upgrades to push their lifespan to beyond 2030. When it comes to stealth technology though, the USA generally takes the cake. Everything from the original stealth F-117 Nighthawk to the upcoming B-21 Raider, all of which have put the country on the map, or rather off it, when it comes to clandestine missions across the world. That, however, might be about to change as Russia gears up to start flight testing its new top-secret bomber project. Now, fair warning before we get into it, it can be a little bit hard to discern between fact and ambitious propaganda, so until this plane is cruising in the skies, its specifications might be rather up in the clouds, so to speak. Dubbed the PAC-DA, it's a next-generation strategic bomber under development at the legendary Tupolev Design Bureau. PAC-DA itself stands for Perspective Aviation Complex for Long-Range Aviation. And long range it will be. With 12,000 kilometers operational range, it will have the ability to fly from Moscow to any city in North America, Rio in Brazil, and even Darwin in Australia. G'day, mate. It doesn't have to worry about refueling, as it can fly its 4 crew members subsonically for up to 30 hours to circle targets or to be hidden deep in the clouds until needed. These engines are so powerful that they can work in -60 to +50 degrees centigrade and survive the effects of even a nuclear explosion. With its 30-ton weapon capacity, it will be able to carry everything from conventional bombs, nuclear missiles, and in the future, hypersonic weapons. So where is this miracle new plane? To understand where we are now, we have to go back to where it all began.
the Tupolev Tu-160. The supersonic strategic bomber has been a staple of the Russian Air Force for decades, ever since it first rolled out in 1981. However, for those viewers who might not have been born in 1981, this is a long time ago. Despite being the fastest, heaviest, and largest supersonic bomber still in use today, among many other records, its technology is based on what was available back in the 1980s. Warfare has changed since then, and new strategic bombers are more often doing the role of a cruise missile carrier rather than irregular bombing missions with guided or unguided bombs. Russians know this and saw how the US used their bombers in recent conflicts and have started learning from their experiences. While there have been rumours of this project back in the 1990s, the first concrete effort to create a new bomber project was in 2007, when the Russian Air Force gave the first set of technical and tactical requirements for the new bomber. The main idea was to create a new aircraft that would be able to match or surpass all the current characteristics of the Tu-160. With the exception of the supersonic speed, which is sacrificed for stealth and maximum load capacity. A number of the Tu-160s were lost during the dissolution of the USSR, with them being stationed in Ukraine at the time. And the Russian bomber fleet has been lacking in that segment, which led to both the need for the Pakta and for a modernization and renewal of the Tu-160 production line. But I'll get back to that in a bit. In 2013, the development was confirmed to have a subsonic flying wing design with an emphasis on stealth technology over speed.
Kuznetsov Design Bureau was awarded the contract to develop the new engines, named NK-65, based on the NK-32 engines currently used by the Tu-160. By 2019, it was confirmed that prototyping was in full swing at the Kazan aviation plant, and it's expected to have ground testing sometime in 2022, with a possible first flight between 2023 and 2024. But let's dig a bit deeper into what actually is the combat purpose and the future of this aircraft. And is the message from the Russian messenger actually getting through? For the first time in their operational history, Russian bombers have had the opportunity to perform combat roles. During 2015 and 16, the Tu-95, Tu-22M and Tu-160 have flown multiple missions in Syria in various roles. The Tu-160s performed attacks with the new Ka-101 cruise missiles, while the Tu-22Ms and Tu-95s performed sorties with both cruise missiles and bombs, testing out the new SVP-24 Hephaestus targeting system, which basically turns dumb bombs into at least a semi-guided munition similar to the US's JDAM, but still lacking in precision. This is important to understand the future of both the Tu-160 and the Pakta. In 2015, it was announced that the production of the Tu-160 would be renewed, with all the current aircraft to be modernized and new ones to be built with the designation Tu-160M2, having a new modernized engines, avionics, comms, glass cockpit, etc. A total of 50 new airframes are planned, with 2 already delivered. So what does that mean for the Pakta? First of all, focus will be on missiles as the main weaponry. Hypersonic missiles like the King Zhao and the new Ha-92 will be featured for sure, along with the stealthy Ha-101 and 102 cruise missiles. As we already mentioned, stealth has been chosen over speed, with extremely long range and great payload capacity. This all leads to be the idea of Russia actually creating a capable preemptive strike aircraft which can hit anywhere in the world. With the US and Russia relations getting worse in recent years, this might be a clear sign that Russia wants to be in the same position as the US with its first strike capabilities, and use this to either further escalate or de-escalate the current situation. Only time will tell.
It's also worth mentioning that this aircraft design isn't actually the only stealth strategic bomber under development. There is also the Chinese Xi'an H-20, a first for the nation, and will look a lot like the B-2 flying wing bomber. Little is known about this project, only that it will have an estimated range of at least 8,500 kilometers and will allow China to reliably reach targets as far away as Hawaii from the mainland, with its 10 tons of conventional nuclear weapons. But just like the PAC-DAR, the Xi'an H-20 is more of a paper project than a reality, and timelines are ever evolving as production and testing continues. And it remains to be seen if the world will watch and learn. Hey, it's Future Nick here. I thought I would just do a quick little thing about the actual 3D model and the 3D design that we used in this video today, just to sort of point out some of the little flaws that some of the viewers have noticed and to just get it sort of out of the way. A lot of people have said that it wouldn't exactly be a stealth bomber if it's got these exposed sort of... See these exposed jet engines here? Like, that doesn't make a lot of sense for a stealth bomber to have this. In fact, we don't even know how many engines this new aircraft will have. So just take that with a little bit of grain of salt. And then, of course, it's not really a flying wing, considering that it's got this middle fuselage part here and then two obvious wings on the side. So flying wing design is a little bit sort of vague in this case. Of course, we also have these winglets here that will help with the range, but that's actually not going to help its stealth characteristics. So yeah, take it with a little grain of salt and just think about it a little bit Hollywood movie magic rather than actual aircraft design. But if you yourself wants to get ahead of the game, just like Russia in the development of their new aircraft, then why don't you become a Patreon? As a Patreon, you get to see videos early, make suggestions, and even talk with me direct. We also have channel members as well if you prefer to stay on YouTube. So to keep this video short, thank you so much for watching.